Hi, this is Callan Bentley. Welcome back for another Smart Figure. In this video, we'll take a look at the evidence that Alfred Wegener presented for the existence of a former supercontinent that he called Pangaea. Alfred Wegener was a German meteorologist. He's shown here in a hut up in Greenland where he went and studied the weather. But he really made a name for himself with his groundbreaking idea of continental drift, the idea that the continents had shifted position over time. Wegener proposed a former supercontinent that he called Pangaea, which comes from the Greek for all the land. And Wegener's conception of Pangaea looks something like the image down in the lower right here. In the modern day, we've retained the name Pangaea, but further evidence has revealed that the supercontinent had a slightly different shape. Wegener got most of it right, but the position of Asia was a little bit off. So, what evidence did Wegener present to support this outlandish claim? Well, first off, he noted that the shapes of the continents fit together very well, almost like pieces of a puzzle. So the most celebrated example of this is the shape of South America fitted together with the shape of Africa. The modern-day coastlines are not actually representative of the shape of these two different continents. Instead, what you have to do is pay attention to the shape of the continental shelf. So when you look at the actual edge of the continental crust, even though it's flooded by seawater, these two fit together very, very snugly with only small gaps and areas of overlap. A second line of evidence came from mountain belts, modern mountain belts. So Wegener looked at the mountain belts that were present in Western Europe, in eastern Greenland, in the eastern part of North America, and in northwestern Africa. And he realized that you could classify these as a bunch of different mountain belts, or if the Atlantic Ocean were completely closed, why those mountain belts fit together and they just became one continuous strip of mountains. So he suggested that these mountains were evidence that these continents were once joined along a little seam before the existence of the Atlantic Ocean. Wegener also looked at rocks, sedimentary rocks, that were evidence of different climates in the past. So if you go to eastern North America, to Europe or North Africa or eastern Asia today, you find evidence that in the past, in the late Paleozoic, there were coal swamps in those areas. So vast areas covered by swampy vegetation that got preserved as coal. And then in South America, in Africa, in India, Australia, and Antarctica, there's evidence of ancient glaciers. Again, the same period of time, the late Paleozoic, but these glacial deposits are spread out over all these different continents. Now, you could explain the situation here in the upper image by talking about bunches of different glaciers. So one set of glaciers in Australia, another in India, and so on, and a bunch of different swamps. But Wegener interpreted it differently. He interpreted it as during Pangaea, all of the continents with the coal swamps were pretty close to the equator, and the continents with the glacial deposits were all pretty close to the South Pole, so that there were actually patterns that could be teased out of this collection of sedimentary rock data. Furthermore, the pattern of glacial striations, the scratches that glaciers leave behind, suggested that they were all part of one massive ice sheet in the past, radiating out from the center of the southern part of Pangaea. Wegener's final line of evidence came from fossil organisms. This is one here. This is Mesosaurus. Mesosaurus is not a dinosaur. This is an organism that is older than the dinosaurs. It's a small freshwater reptile. You can see from the scale here in the upper left that it's not very big. It's only a few inches long, about a foot, foot and a half long, something like that. Well, you can go and find Mesosaurus fossils in both South America and in Africa. And so you can explain that distribution of fossil Mesosaurus by saying, okay, well, there were two different populations of Mesosaurus, one on each continent, or you could explain it by saying this is one continuous population that extended across that whole area, and then later it was broken apart by continental drift, and Africa moved away from South America. Mesosaurus isn't the only organism you can play this game with. Lystrosaurus is another example found in Africa, India, and Antarctica. Or you can even look at plants like Glossopteris, a Paleozoic seed fern which is known from fossil deposits in South America, Africa, Madagascar, India, Antarctica, and Australia. You could say that that's one continuous belt of Glossopteris vegetation that was only later broken apart by continental drift. That's how Wegener interpreted it. So, for review, when you look at a reconstruction of Pangaea, can you use this map to illustrate the 4 different lines of evidence that Wegener used in suggesting continental drift? Go ahead and pause the video for a second and see if you can come up with all 4, and then we'll review in just a moment. Welcome back. Let's see if you got the modern mountain belts that basically extended along the boundary between the different continents, or perhaps the shape of the different continents fitting together, the presence of coal swamps along the old equator and glacial deposits over the old South Pole, and then lastly, the fossil organisms that ranged across one continent onto the next. If you got all 4, congratulations. You have a thorough understanding of Wegener's presentation of continental drift. Thanks so much for your attention. This has been another Smart Figure.